Alright, so today we're doing a quick lesson, right? We are going to need our inverse. So first things first, this isn't on your paper, but I want to talk about it. This is the reason why we're doing it. So real life example, if a group travels on a bus, it costs $3 per child, $320 per adult, total of $118.40. Take a train back, $350 per child, $360 per adult, total of $135.20. How many children, how many adults? So, normally in the past, you have set this up as a system of equations. Right? Does everyone remember what a system of equations is? Right? It would look like per child would be 3x plus per adult 3.2y is $118.40. 350 per child, so 3.5x plus 3.6y equals 135.20. Right? We've all seen something like this before, right? We should have seen it last year. You've probably solved them before. Right? We're going to do it again, Unit 8 this semester. But the easiest way to solve these problems is by setting them up into matrices. Right? 3, 3.2, 3.5, 3.6 are two variables, x, and you could write y if you wanted, and then the two answers. Right? So this systems of equations is the same as setting up in a matrix. And when we do our systems of equations, or solving systems unit, we're actually going to use matrices for some of them. Right? So you are going to remember matrices. It's crazy. So that's the reason why we do solve these equations, because we're going to come back to it in probably Unit 8 for Semester 1. Okay? So, when I'm doing this, I'm looking at it. I have three different parts to my matrix equation. I have a coefficient matrix, a variable matrix, and a constant matrix. Well, the variable matrix is pretty easy to figure out because it's variables, right? It's x and y, it's x, y, z, whatever it might be. The first one, though, why do you think it's called a coefficient matrix? What is a coefficient? Does anyone remember? The what? The number in front of a variable. So if you look back here, what do you notice about our coefficient matrix and our coefficients? They're the same, right? So the coefficient matrix is just the numbers that would be in front of the variables if I had written it out into a system. Alright, so it's called the coefficient matrix, variable matrix, and the constant matrix is just what they would equal. Okay? How we solve something like this, if I want to solve for x and y, is I'm going to take the inverse of A times B. The inverse of A times B, or the inverse of my coefficient matrix. So 7, 5, 3, negative 2 to the negative 1 power, so I want the inverse. And I'm going to multiply by B, or my constant matrix. So times 3, 22. Right? You need to write this out. This has to be written out on a test. Because then what you can do is you can plug this right in your calculator. Okay? If you don't write that out, you just tell me what x and y are, what do you think is going to happen?
Get it wrong.
You're going to get it marked wrong, right? I don't know what you did to get those. I need to see that. So you need to show me what you're putting in your calculator. So if I have that written down, I'm going to go to my calculator. Oops, I don't want math. Alpha zoom. I want a 2 by 2. I'm going to plug that first one in there. Not the right packet. This is the right packet. Alright. So I have 7, 5, 3, negative 2. And I said I want the inverse of that matrix times alpha zoom. I want a 2 by 1. 6. Times 3, 22. And if I hit enter on that, it's going to give me an answer, 4, negative 5. Right, so I go over here, I write 4, negative 5. Do you think I should circle that matrix? Should that be my answer? No. What did we say we were looking for, though? X and y. So 4, negative 5 is the same as x, y. Now, do not circle that matrix. Do not circle 4, negative 5 and think you're done. Right? I don't know what that means then. It can mean anything. So what I want you to do is I want you to write out, in this case we have lines for you, x equals 4, so in the same spot, y equals negative 5. And that's a good answer. Okay? So you're taking the inverse of your first matrix, your coefficient matrix, times your second matrix, your constant matrix. Alright? I'll help you set the next two up. We only have 2 problems to do, then we're done. And then you get your homework. Deal? Alright. So first one, I'm going to take my coefficient matrix. 2, 1, 3, 2. Now the inverse of it times my constant matrix. 0, negative 2. Alright, do it in your calculators. Let me know what you get. Do it in your calculator. Like I said, guys, make sure you're showing me what you're putting in your calculator. Make sure you write that down or it's going to get marked wrong. Alright, so we get an answer? 2, negative 4?
Yes.
Is that how I should write my answer?
No.
No, right? X equals 2, y equals negative 4. Good. Alright, one more. Do it quickly. Take your first matrix, your coefficient matrix, 1, 5, 2, negative 3. Inverse of that times my constant matrix, 10, 7. Do you have it? Okay, hold on. I'm going to give people a couple seconds. I don't know if they started it yet or not. And then you can tell us the answer. Alright, what'd you get?
5, 1.
So how'd you write your answer?
5 and X.
X equals 5, y equals 1. Perfect. Any questions?